can see that I have given the introduction and presentation topics. First of is introduction to nanotechnology, basics of energy storage. Then I'll talk about advanced energy storage devices, nanotechnology for energy storage devices. Then trending battery technology and how you students can contribute from your side, from wherever you are currently, you can contribute to the nanotechnology through energy storage devices. Then summary and Q&A session. If you go to the next slide, you will see that I have given an introduction about the uh, nanotechnology. I will answer this question throughout my presentation, that how big or small things that, I mean, nanotechnology makes a difference. What is nanotechnology? Can we see invisible? I mean, with our naked eye that we cannot see, nanotechnology is able to show us or not? Can we see invisible? Will we live forever? For example, sometimes people think, okay, if we can control the individual molecules in nano level, so actually the whole body is a constitute of I can say nanotechnology, because every molecules is a part of nanotechnology. So actually, do we really need the nanotechnology or nano in terms of that? If you go to the next slide, if you see that, I think you all know these things. This right side, as you can see, it's a Great Wall in China. It's very big, and you can see it from the moon. It's that much big. So when it comes a little bit shrinking and then go to the level of your fingertip, you can see some chips, right? Nanochips. You can call it nanochips. And people know it very well, nanochips. But if you see inside this fingertip that you can see in the right side, that it has a lot of features. And as you know, that thousands of millions of transistors are actually fitted in this fingertip, in this small chips, microchips, or it's called nanochips actually. So how people make these things happen? Because nanotechnology, when it comes into the action, this thing actually happen. So I want to give you some introduction about, I mean, the scale at first. Then I will go step by step, and then we will learn the nanotechnology basics, and then how we can apply for the energy storage devices. That first, if you see that which is called theta and x, that is about 1815 scale. In that scale, you can think about the astronomical scale, which is called, you can think that nearest galaxy, moon, uh, the light year, light and sun distance between
Ikramul, do
those
you want to try
distance.
sharing the presentation from your screen? Because I think if you just turn off your video, I think you'll be fine.
Let me try then. You can turn off the
Yeah.
presentation then. Let me try with the PDF version.
Okay. Now
Is
let's hear
it
you.
okay?
It's
My voice is okay?
keep talking. So far, it's perfect.
Okay.
Okay,
Let
yeah, we're good.
me
Yeah,
share
this
it
is much
then.
better for you to
Okay.
share it. Because then you can control how you want to
Definitely.
move it.
Right, exactly. So I think you can see the screen, right? So this is the nano, how big is nano? I was talking about it. First of all, you can think atomic scale, which is, sorry, astronomical scale. Then we come to the terrestrial scale. That means the circumference of the Earth is very big, but it's smaller than the astronomical scale, right? So you can think the thickness of the Earth crust, height of the Mount Everest, depth of the ocean. So these are actually terrestrial scale. That means that you can sense that it's present inside the Earth, but it is smaller than the astronomical scale, which is very big. The light year, the galaxy, which are very big. So actually, you can Also think about the digital road system, rail system, water distribution. You can imagine how big it is. And if you come a little smaller and you think about the uh, human scale, you can see that there is your foot, your head, your hair. So those are human scale. But even if you go a little bit smaller, your hair is just 2 micrometer in diameter. But if you think what is this 2 micrometer, it is actually 2000 nanometer. 2000 nanometer. So you can imagine just our hair is 2000 nanometer. So we are just going down and going smaller, more small. Then you can think about the molecular scale. The molecular scale, also atomic scale. This actually falls into the nano scale that you can see in the last. This is 10 to the power minus 9. That means 1 of a billion is a nanometer. If you just divide 1 nanometer of it, one nanometer in 1 billion, you can see that it's a 1 nanometer. So it's 10 to the power 9. And then you have the subatomic scale, which is electron, neutron, proton. This is even lower than nanoscale. It's 10 to the power 12, at minus 12. That means 1,000 times smaller than the nanoscale. So if you
Ikramul,
want
I have a
to,
question.
yes,
When they do
yeah, sure.
DNA engineering, genetic engineering, where is that considered?
And nanoengineering,
Yes, when they're doing
uh,
genetic engineering for like plants and seeds.
okay. Nanoengineering means you can control the individual molecular level. So you can do it in with chemistry mostly. For example, you want to make a nanomaterial. So if you dissolve your precursors in the solution and it reacts with each other and make a tiny small particles, which is nanomaterial. And you can also reshape the particle, spherical size. Also, you can even define how big it could be through the adding chemicals. For example, if you add some more chemicals, your particle size will be bigger. If you stop the adding, your particle size will be lower. So that's how we can control, and it's called actually nano engineering. You can also think about thin films. If you think about the thin films electronics that is now very popular, which is called actually printed electronics. You can coat certain layer on your skin or on a very thin paper, and you can use it as an electronic device. So it's called nano engineering. It's actually falling to the nano engineering category. So that's how people are actually trying to control the nano scale. And that's how the term is coming, nano engineering. So that's why we are calling it nano engineering. So next, if you see that a nanometer is actually, as I said, is 1 of a billionth and thousands millionth. So a red blood cell is actually 7,000 nanometer wide. That you cannot even see. But you can see the blood, but you cannot see the blood cell, which is actually 7 micrometer. If you think about micro, that means 7 nanometer. So you cannot see this in your with your eyes, in naked eyes. Then a water molecule is almost 0.3 nanometer across. You can see the water, but there are a lot of thousands of millions, billions of molecules that makes the water. You cannot see the individual molecule. This is actually is very, very thin, zero point 0.3 nanometer, one molecule of water. As I already mentioned, average human hair is 100 micron. That means 100,000 nanometers. Even the so hydrogen atom is lined up with measured about 1 nanometer. So those are some idea about the nanoscale. So if you go to the next slide, you can see that uh, these are the classification of nanotechnology or some nanomaterials. First of all, you can see there is zero dimensional, which is called 0D. Actually, zero dimensional means all of the three scales, that means length, width, and height, everything is in nanoscale. That's why we called it zero dimensional. If you want, if maybe you have heard about the quantum dots, or quantum computing, right? So this quantum computing or quantum dots fall into this category, zero dimensional. That means all the three scales are in nanoscale. Then there is one dimensional, which is only. That means two dimensions are in nanoscale, and other dimension is normal scale. That means in bigger than nanometer. So this is called 1D. Then when you have 2D, that means one dimension at nanoscale, two dimension in normal scale, which is called nanosheet, nanofields, actually called 2D. So when you have 3D, then you actually have the real life material, which is called 3D. So why nanotechnology is so important right now? Because it's incredibly broad interdisciplinary. Energy storage, as I've said, and today is our topic is energy storage, defense, security, sophisticated defense systems, analyzing data, it needs nanotechnology, metallurgy materials, electronics. As I have said, electronics, optical engineering, communication, optical optoelectronics or photonics is actually use the nanoscale. Then biomedical and drug delivery. Maybe you have heard about it. Drug delivery can now be done on a targeted place. That means you can put your drug and make it a nanobot or nanorobot, and you can control it from outside with a remote control or giving some electromagnetic field. And then when it reaches to the destination where the problematic cells exist, you just open the medicine or you just blast it, and then your problematic cells can be cured. So this is powered by medical drug delivery. Agriculture, food. You know that people are now using agriculture, I mean nanotechnology in agriculture side to make nano fertilizers. So what is nanofertilizer? When you have fertilizer in liquid, the molecules inside the liquid go into nano level. When you apply it in the um, in soil inside your field, it gets really absorbed with the soil very fast. That's why people are also using these nano fertilizers in agriculture. Also, food. Sometimes food also being processed using nanotechnology. That's why you can even store the food for more days. Then there is cosmetics and paints, which use nanotechnology. And then biotechnology, and of course textile. Our textile cloth that we're wearing now is actually using also nanotechnology, whether it is for dyeing it, whether it is for making the swing that you are using also the thread. It can be also used nanotechnology to make. Then, according to the scientific disciplines, physics, chemistry, material science, biology, all of them are necessary. So it is actually the boundary between atoms and molecules and the macro, as I have said, where ultimately the properties are dictated by the fundamental behavior of atoms. So those are the necessity or the significance of nanotechnology, and you can understand in nanotechnology or nanoengineering actually constitute all the major discipline of science. So this is the man who actually gave the idea of nanotechnology. So his name is Richard E. Feynman. Maybe some of you have heard about it. There is a famous lecture, you can also see it in YouTube, that you can see that there is a plenty of room at the bottom. If you search with this name, there's plenty of room at the bottom. You can see that a man wearing a half pant and giving lectures about nanotechnology. So this guy is actually give the idea nanotechnology, and he also suggested the quantum mechanics, the very sophisticated physics that he even said quantum mechanics is even he even cannot sometimes explain it fully. So that's the one who is the one who actually take this idea into broad daylight and say nanotechnology can help us to make everything shrink in a very small section. For example, he said an entire encyclopedia can be written on a pinhead. How? If you expand it in nanoscale, a pinhead is actually thousands of micrometers, so thousands of nanometers. If your one word is just 1 nanometer, you can even put millions of billions of letters inside it. So this is just an idea. So you can understand when I'm saying all everything, the nanotechnology is actually an expansion and shrinking. So you need some instrument to do this. If you cannot shrink or if you cannot see the nano level size, you cannot do anything or you cannot engineer it. So that's what the idea he gave, that if you can see in this level what is there and you can see some property and then change some property, you can actually control it and you can create nanotechnology. Then this is the another one that I want to mention here, that as I've said, physical or chemical properties, nanotechnology can be play a very important role here. For example, we are also working on different types of nanomaterial for energy storage devices. I'm actually working on lithium-ion battery. So we are, for example, sometimes synthesizing some material, mixing some chemicals, and the mixing, even the speed of mixing can give you nanomaterial, or if you mix it more, the particle size will be higher. So how it happens? At first, when one atom or one molecule is created through the reaction, other molecules actually grow in on the surface of it, and they attach with each other and make a crystal, which is called nanocrystal. When you stir it more, when you stir it more and more, then all more particles comes together, atoms comes together and make a nanomaterial. So that's why the nanomaterial is so important in chemistry, chemical engineering, biological, also drug delivery, as I've mentioned, the solubility, the color even. For example, if you heard about the quantum dots, quantum dot, if it dissolve in a water, it can give a different color in UV spectrum. For example, if your intensity is higher, you can see red light from that quantum dot solution. If your intensity is low, you can see blue light, for example. Then I have also mentioned the quantum mechanics, and that's what people are using it to make quantum computers. So these quantum computers, what is used is actually, there are a lot of ideas about it. So there is one idea about the molecular computing as well. For example, if we can use the individual molecules or atoms as a signal 1 or 0, if you just can create 1 or 0 from these molecules, or if you can imitate or make something that actually imitates 1 or 0, you can make a quantum computer or molecular computer from that as well. So that's why this is very interesting about nanoscale. If you think, you can imagine at least something. So now I will talk about actually how the shrinking changes everything. For example, if you see a cube like this, a big cube, so there are 9 blocks in every face. So there are 3 sides. So totally there are 54 surfaces, and volume is about 27. If you just cut one line of it from both every side, and you have just this two side, which is surface of just 24 surface area. Volume is just 8. When you have just one unit, you have just one side and 6 surface, and volume is just 1 meter cube. Then you can see this one is actually just, if you just put in the Rubik cube, you have totally volume of 27. When you are cutting it, you have just one. That you just shrink it 27 times. The surface to volume ratio is 2 here, but surface to volume ratio is 1 here. So this is very important in energy storage devices, in nanotechnology, energy storage devices, because we know that when you have nanomaterial, its expansion and its property changes. Its molecular, even mechanical property changes. For example, we are working with the silicon anode, and silicon anode, it has a very interesting property. When the size of the silicon particle is big, very big, for example, very big means micrometer scale, a couple of micrometers, then it cracks very early. For example, if you just cycle it for 2, 3, 20, 30, 100 cycles, your material will be degraded, your battery will lose its capacity because of the delamination happens. But if you make this silicon nanosize, that means nanoparticle, you can cycle it for thousands cycle. So you can understand that just a size of a nanoparticle changes its mechanical property. Also, the energy storage property is also changing. So that's why the shrinking is important and also plays a role in even mechanical strength that you can even see with your eyes. For example, if you know about the ferrite core that uses in the toroid making some inductors, the round shaped ferrite core. If your material is nano sized, your magnetization can be very different. Even you can make a super magnet. If you can, crystallographically orient it, you can also make a super magnet with it. And if you have nanomaterial, you can do that. But without nanomaterial, it is hard. So that's how the shrinking is actually changing everything. Now, I will give another example of shrinking. Maybe you have seen this spider walking on the water, right? If you go to the countryside or any village side in the water or in the river water sometimes, you can see this type of spiders. So how it is actually doing this? How this one is just a very small, for example, just pin of a ball pen. If you head of a ball pen, if you just put this head, it will go down. But this much big insect is walking on the water. How it is happening? Nanotechnology is actually giving you this opportunity. When you have this nanotechnology, if you can use it for understanding it. For example, when this insect put its legs on the water, it actually uses its surface tension. It actually expands the surface tension in every side. For example, if you just put anything on that, it will give all of its force downward directly to the deep of the water. But this guy, this spider, do not do that. It actually expands its surface tension around its leg. As you can see, the water is actually a little bit down, not exactly straight. This is actually happening due to nanotechnology. This legs has very tiny uh, type furry uh, portion that actually enables it to wet the surface, and then it actually gives the weightability of it, and then the surface tension changes, and that's how it actually able to work on the water. Actually, now using this technology, people are trying to work on the water. I have seen one guy trying to do some experiment with similar types of legs. Not exactly this one, but there are some types of expanded legs or shoes he was using, and he was trying to walk on the surface of the water, and he was able to do some for it for some time. So people are trying to do that. If maybe it's I will not or you should not be very surprised if you see after few months that people have invented some technology or some devices that you can use to walk on the surface of the water. So if you see, you should thank to this spider who actually give the inventors idea that these things can also happen in the nanoscale if you have that nanotechnology in your hand. So if you go to the next one, you will see that I have given. Actually, we're now going to the energy storage. All the examples of nanotechnology, the incredibility of nanotechnology is I have given. So now we will go to the energy storage and we will try to relate the energy storage and the nanotechnology together. So I put here a periodic table. Maybe some of you know about it who know chemistry or science. The first group has hydrogen, lithium, sodium, then beryllium, magnesium. So all of them have different molecular size. And in atomic scale, it has one size. When it is ionic state, it has a different size. Today, our topic is about lithium and lithium ion battery mostly. Well, I will talk about other research technology as well, battery technology as well, but the most focus will be given on lithium. Because if you can see, lithium is the lightest metal present on Earth. Why? Hydrogen is just atomic number one. Helium is atomic number two. Helium is inert gas. It do not react with anything. It's an inert gas. So you cannot do anything with helium. Hydrogen also very volatile and very flammable. You know it. So these two are not metal. The next one is lithium. So lithium is the lightest metal present on Earth. So you can imagine it's the lightest and is smallest in size. If it is in ionic state, the sizes even get smaller. So this lithium ion will be very easy to pass from anode to cathode. Actually, this anode to cathode back and forth, charging, discharging, actually enables the lithium ion battery to perform the best. That's why I put this to visualize, to imagine how lithium ion is actually doing this, while others capacity are not that high. For example, lead acid battery, nickel cadmium battery, those are not that high in capacity. Why? This is the reason. So I will give some brief introduction about lithium battery. If you attended my other classes, you maybe know about it, but I know most of you are new in this class. So I will give a brief introduction about it. So you can see a lithium battery internal circuitry, internal view here. There is an anode, there is a cathode, and there is a electrolyte in the middle of it. The electrolyte is everywhere in here. And in anode, you have carbon. Carbon, as you know, is an hexagonal structure. Graphite is mostly used. Then in cathode, you have lithium cobalt oxide, lithium ferrophosphate. So lithium is inside and there are other. Lithium is remain here as a composite. So lithium is there, other component is there, but only lithium will go back and forth during this turn. So how it happens? What is nanotechnology here? This membrane, which is called the separator, you can see it has very nano-sized pores. As I said, lithium is actually a nano-sized ion. So this membrane are designed and engineered in a way that it only allows the lithium to pass. As I said, lithium is the smallest ion. So with this smallest pores or membrane, only lithium will pass back and forth. Anything else will not go back and forth because this membrane will block them. And this actually done with the nanotechnology, also nanoengineering, this membrane use nanotechnology. So what happens when we charge it, the lithium from the cathode go through this membrane and electrolyte and reside here and stay here. When you discharge it, the opposite things happens. The lithium go back to the cathode and the electron passes through circuitry and you can see electricity on the outer circuitry. So these are the mechanism and also you can see now and I hope you can understand now how nanotechnology is coming into the picture here. So this is actually a broader, more broad view. For example, cathode reaction, anode reaction, and overall reaction is given here. So I will give you as an self study for that. I will not go through this much more because our topic is about nanotechnology and relation between them. So these are actually just shown how the fully charged state and a little bit discharged state, then fully discharged and fully charged state look like, and the visualization of it. Then I will talk about the anode. As I have said, the anode uses carbon, and carbon is mostly graphite. As you can see here, there are a lot of different types of uh, graphite, anode material. These are carbon, calcium dioxide, silicon based. I have said silicon based material is also tin based material can also be used as anode. So if you see the right side of it, so the capacity of graphite is low and the lithium has the highest capacity. So lithium metal is the best as anode. But there is a problem with lithium metal. What? When you use the lithium metal itself as an anode, during charging and discharging, it grows dendrites on the surface of the lithium. And these dendrites is actually dangerous. It actually crosses the membrane and it actually make it short circuit. And it become short circuit with these dendrites. So you cannot use lithium metal. So there are other things transition metal oxide, but those things, as I have mentioned, it cracks very early. Silicon, very good capacity, cracks very early. But graphite is very stable. But what gives that stability? To understand this, you need to know the nanotechnology. Here is the nanotechnology, and you will be able to understand it very well if I explain it. You know graphite, you know it anyways every day. You have pencils in your hand, and pencil head is actually graphite. And if you rub it with your hand, you can feel that it is very like lubrication, very slippery. What makes this slippery? This is actually nanotechnology. Actually, graphite is hexagonal sheet structure. It has multiple hexagonal layer, one after another, which is connected with the van der Waals bond, which is very weak. So when you rub it, so these layers actually move on another one after another. It is actually very easy to move. That's why you see it very slippery. So there is a gap when you can move different layers. So there is a gap. So this gap is actually 0.34 nanometers, and the gap in one hexagonal structure is 0.14 nanometer between these two. As you can see, there are spaces in layer by layer. In between this layer, there is a space, and also inside the every hexagonal shape that six close in carbon atom makes. Lithium can reside here as well. As you can see, lithium can reside inside this hexagonal structure. Also, it can reside stay between these two layers adjacent to each other. Why? You can see the size 0.34 nanometer on lithium ion is much smaller than this size, but it fits well there. So that's why the nanotechnology is coming into play here, and you can also understand the capacity from here. Why it has low capacity? If you see that graphite has low capacity, as I said, this is the explanation you can see here. See, some of the hexagonal closed surface have no lithium, right? Why? because this lithium cannot reside side by side hexagonal structures. Because if lithium is there, this was already bonded with this lithium. So it cannot make any bond of lithium inside this adjacent layers. That's why in one lithium, for example, this lithium, you can see six uh, hexagonal closed area should be empty. That means 1 of 6 ratio. That means 6 carbon atom will just hold one lithium. That's why the capacity is lower. But it's very stable because it has the place to keep the lithium inside and without even expanding because it has already the space. That's why this carbon or graphite is very, very stable, but it is not very good in capacity. That's the explanation. So people are trying to make the capacity better. So they are trying to integrate silicon with it because silicon has very good capacity, but its degradation is very fast. So what I have said earlier that if you make this nano size silicon particle, your expansion can be lower. And then again, people trying to do carbon coating on the surface of silicon and making it a silicon carbon nano composite nano anode. So that's how when silicon is already nano size, its expansion is degraded. Then you have carbon layer. So now the lithium do not come directly contact with the silicon, the capacity increases very high. So why you are talking about the lithium and battery? Because I have already mentioned it. Now you can see that combustion engine can drive you, for example, more than 600, 700 kilometer. You have this 50-liter tank. So if you want to use a lithium-ion system in your vehicle, you cannot go beyond 300 kilometer right now because of the size of the battery is very high. The other battery technology here, those are even smaller in driving range because of the size. So people are trying to make this one similar to the combustion engine. And now you have different types of vehicles. Different companies are even offering 600 kilometer, 1000 kilometer range. How it is happening? Because of this lithium and battery technology improvement. People are trying to integrate silicon. People are trying to make more, trying to store more lithium in the anode and trying to get more capacity from there. So these are different battery technologies as you can see earlier. It has very low capacity, low energy and power density, and lithium battery is actually here. So it has actually a balanced energy and power density. There are other technologies, lithium, battery, nickel, cadmium, nickel metal hydride, nickel cadmium battery. You also use it in your trimmer. Also, it is very common in the rechargeable toys. Nickel metal hydride battery, sodium sulfur is a new technology, redox new technology. Sodium ion battery is also very new. Lithium air battery as well. I'll just give brief introduction in 1 or 2 minutes in every different types of battery. Then maybe within a few minutes we'll go to the question and answer session. So this is nickel cadmium battery. So as you can understand from the name, nickel and cadmium. Cadmium is actually anode, and nickel hydroxide is the anode cathode here. And there is a potassium hydroxide electrolyte. So hydroxide ion actually passes through vacuum flow, and then charging and discharging happens, and you get electricity from the anode and cathode electrons. Then you have nickel hydride battery, similar things. Nickel as an anode metal hydride, nickel hydroxide is a cathode. Then you have a hydroxide ion passing through each other. So you can get the electricity flow. So this is another new technology which is now developing, which is sodium sulfur battery. Sodium as a negative electrode, which is anode, and positive electrode is sulfur. So when this sodium goes to the positive electrode, that is cathode, make a composite which is sodium sulfur, and that when it's coming back, it's actually coming back through this negative electrode as a sodium. So this back and forth electrode goes and make bond, and then again break the bond and comes into the anode. This actually gives electricity, but there is a problem. Those electrolyte and material should be in liquid state, and you need 300 degrees Celsius to keep the electrode material in molten state. So understand, it is not easy to do that. So not very popular, but people are also trying to do that. But they have some different applications like missiles and high temperature applications. The redox flow battery. For example, this one is actually pumping electrolyte when you need. And there are a lot of electrolyte in our reactor site. When the charging and discharging happening, you just pump the electrolyte here and charge it, and then after discharging it, you again pump it back. Because this electrolyte is actually charging the battery. You do not need to do anything. When you have the load connected, you will discharge the battery, just pump the electrolyte back, and then the battery will be charged. So this is how the redox flow battery works. Then there is sodium ion battery. This is very trending, and people are also thinking about it with the lithium ion battery. But there is a problem of capacity. Capacity is very low in sodium ion battery. As you can understand, this is very similar to lithium ion battery, carbon anode as an anode, and then cathode sodium cobalt oxide, or even that lithium cobalt oxide, some battery that has sodium. But the good thing is you can use your regular salt, that is sodium chloride as an electrolyte here, which is not flammable. This is very good thing about sodium. People are using it, and even I have seen that one Chinese company. I have forgot the name of it. Sorry, no, Farasis Energy. They actually launched the sodium ion battery commercially production for the EV. Though this is very initial immature level, but they are trying to they show it to the market that they're able to do that, and it's possible. It's possible. There is the last one, which is lithium air battery. This is very interesting. So you have lithium anode, but in cathode there is no material. Just some air you pass, you allow some air to come and stuck it in the membrane or pores of it, and when lithium comes here, the lithium peroxide, Li2O2, forms here. And then when it will discharge, it lithium goes back. So this back and forth charge and discharge actually gives you energy. But there is a problem with it. Its electrolytic motive force or the voltage of it is lower. Normally lithium might have 3.2 or 3.6 volt, but it has the 2.96 volt. And also it has very low amount of cycle life. You can charge it very fast, but life cycle is very low. Within 50 cycles, you need to change the cathode again. So these are the advanced energy storage devices, as I've already mentioned, and people are also trying to integrate more cells in different pack size, and then making a battery for electric vehicle with energy storage. There is also fuel cell, supercapacitors. These are also the different types of forms of battery, but these have other capacity, lower capacity than this. So trending battery technology is focusing on safety, fast charging, extended life cycle. The cost, there are some challenges, which is the cost is very high, you need to go down out of your material requirement, 99.996 is necessary for the battery material, not fully developed because as I've said, it's still developing. Even sodium, lithium itself is developing. The charging infrastructure is not fully developed, just the creating problem. And you know all about the Tesla, the BYD. They are also a very good company of Chinese car maker, electric vehicle maker. Samsung Toyota is also coming into the picture in the business of lithium and battery. And you can see here the in 1970s, the battery has the highest market share or the cell mass specific energy. But today, lithium and battery actually has the highest energy density and also have the highest market share. So how you can contribute as a student, you can start researching on different topics of lithium and battery. You can just, if you do not have anything, any chemical, you can use consonances to design the thermal stability of the battery. Consonances, you can buy the software, use it, and for designing lithium battery. You can also design the chemistry inside. Also, if you have the lab or if you have some material or chemicals, and you can buy one potential start to do the research and do some electrochemical impedance spectroscopy or cyclic voltammetry. And from that, you can also research about and also predict the battery capacity of the material as well. So these are the summary. We have learned about nanotechnology basics, how energy storage, nanotechnology relates with each other, what the advanced and trending battery devices, and your area of possible contributions. So this all from